How do hypersonic missiles actually work? Imagine a weapon that could travel from New York to Los Angeles in under 30 minutes. That's not science fiction anymore. That's a hypersonic missile, a piece of technology that pushes the very limits of what we thought was possible. We're talking about weapons that move faster than a mile every single second, speeds over Mach 5. But how do you get something to fly that fast through the air without it just burning to a crisp? And what is it that makes these weapons so incredibly difficult to stop? We're going to break down the revolutionary science behind hypersonic flight, from the mind-bending engines to the exotic materials that hold it all. Section 1. The threat. So, why is everyone talking about hypersonic missiles? What makes them such a massive game changer for militaries around the world? It really boils down to two key things: their speed and their maneuverability. Now, you might be thinking, don't ballistic missiles also travel at hypersonic speeds? And they do. But they fly on a high, predictable arc through space, almost like a long-range cannonball. Defense systems can track that arc, calculate where it's going, and have a good shot at intercepting it. Hypersonic missiles are a whole different beast. They fly much lower, within the upper parts of the atmosphere. And here's the real kicker: they can change direction mid-flight. This combination of raw speed and an unpredictable flight path creates a nightmare for even the most advanced radar systems. There's far less time to see them coming, and almost no time to do anything about it. Section 2. The two paths to hypersonic flight actually achieve that incredible performance. Well, engineers have come up with two main flavors of hypersonic weapons: hypersonic glide vehicles and hypersonic cruise missiles. A hypersonic glide vehicle starts its life strapped to a powerful rocket, which launches it to an extremely high altitude at incredible speed. Once it reaches the edge of space, the glide vehicle separates from its rocket booster. From there, it doesn't just fall. It glides back to Earth, using its aerodynamic shape to skip along the upper atmosphere, kind of like a flat stone skipping across water. During this entire unpowered glide, it can pull off sharp maneuvers, making its final target a complete mystery until the last few moments. Then you have the hypersonic cruise missile. This one works more like a futuristic jet. It's powered for its entire flight by a wild new type of engine called a scramjet. So, unlike the glide vehicle that gets one big push at the beginning, the cruise missile maintains its own hypersonic speed the whole way, flying at lower altitudes and using its engine to power through any maneuvers. Section 3. The engine of the future. That engine, the scramjet. What even is it? A regular jet engine has spinning fan blades in the front to suck in and compress air. But at hypersonic speeds, that's completely impossible. The blades would tear themselves apart instantly. A scramjet, on the other hand, has almost no major moving parts. The name itself is short for supersonic combustion ramjet. It uses the missile's own incredible forward speed to ram massive amounts of air into the engine, which compresses itself due to the sheer velocity. Fuel, typically hydrogen, is then injected into this supercompressed, incredibly hot air, and combustion happens in a fraction of a second. This process creates a phenomenal amount of thrust, propelling the missile forward at speeds beyond Mach 5. The biggest challenge is just keeping that combustion stable. The air is moving so fast at lighting the fuel, and keeping it lit has been compared to trying to light a match in a hurricane. But when you get it right, it's an amazingly efficient way to fly at extreme speeds. Section 4. Surviving the Inferno's revolutionary engine is only half the battle. At hypersonic speeds, the friction with air molecules generates an unbelievable amount of heat. Surface temperatures can soar past 2,000 degrees Celsius. That's hot enough to melt most metals. Simply keeping the missile from destroying itself is one of the biggest engineering hurdles. This is where materials science gets really interesting. Hypersonic vehicles are built from some of the most advanced materials on the planet. Scientists are using exotic ceramic composites like silicon carbide, which are incredibly resistant to heat. They also rely on special nickel-based superalloys and even newer materials called ultra-high temperature ceramics, or UHTCs, which are designed specifically to withstand these punishing conditions. These materials are all that stand between the missile as sensitive electronics and guidance systems, being completely incinerated during flight. Section 5. The implications. So, what does all of this mean for the world? The arrival of hypersonic weapons has kicked off a new global arms race, with the United States, Russia, and China all investing heavily in their development. Their ability to evade detection and bypass conventional defenses presents a seriously destabilizing threat to global security. Defending against them is a monumental task. It requires a whole new generation of space-based sensors that can track these lower-flying, maneuvering threats from above, and interceptors that are fast and agile enough to actually catch them. Countries are now scrambling to develop counter-hypersonic technologies just to meet this new challenge. The science behind hypersonic missiles is pushing the known boundaries of propulsion, aerodynamics, and materials engineering. It's a field where physics and military strategy are colliding at over a mile a second. I'm curious, what do you think is the single most significant challenge in developing this technology? Is it the engine, the materials, or something else entirely? Let us know your thoughts in the comments below. And if you enjoy learning about the technology that is shaping our world, make sure to subscribe. Thanks for watching.